All right, so we are moving on to our next lesson. Our next lesson is section 1.3, and this is on variables and expressions. Now, before we actually get into anything about this section, I have a job for you. And this is going to be a tricky job, but we're going to see how well you do with it. I'm going to give you 5 words. Your job is to come up with as many words or phrases that mean exactly the same thing as one of the words that I'm going to put up on here. So for example, the first word is addition. So I want you to come up with as many words or phrases that also mean addition. I want you to do the word subtraction. I want you to do the word multiplication. The word division. And the word equals. So your job is to come up with as many words or phrases as you could come up with and think of that mean one of those 5 words. So pause the recording right now and take maybe about 5 minutes to come up with the words that you think would fall under each of those headings. I'm not going to give you a list tonight, but we are going to discuss it in class tomorrow. So come prepared with your list, and we'll see how you do. All right, so hopefully you've come up with some great lists. But let's talk a little bit about variables and expressions. And throughout this, I might drop a few hints of some of what could have been on your list, but we'll see how that works. So let's talk about the word algebra for a second. Algebra is a branch of mathematics that uses symbols. So instead of always having numbers, now all of a sudden our numbers are going to disappear and we might use different types of looking symbols. Now, some symbols could be the operation symbols, add, subtract, multiply, divide. But some of those symbols could be variables. So some of those symbols are possibly variables. And a variable is a letter or symbol that's used to represent an unknown value. Now, interestingly enough, when I was in college, and when you get to that high level of math, you find that you start going through every letter of the alphabet. Matter of fact, we used every capital letter, every lowercase letter, we even used scripted letters to mean something different. So we're talking, there's 26 letters in the alphabet. If you will use just the upper and lower case, that's 52 right there that are gone, and every one of them has a meaning. Then you get to the scripted ones, and you could just even double it from there. So we had to find another way of representing using symbols, because after 104, we're done. So we went into other areas, and we found that we started using the Greek alphabet. Not the Greek, sorry, the Roman alphabet. No, it's our Greek. Alpha, beta, gamma, delta is the Greek alphabet. So we went through the Greek alphabet, and all of those letters, both upper and lower case, got used. So now we've got all these variables and all meaning different things. But we ran out of them again, and they needed yet another alphabet. I want you to think, what other alphabet do you think we could use in math to represent or to use as symbols or variables? And I'm not going to tell you that until tomorrow, but you're going to come in, I want you to come in and ask me that question, what other alphabet do you think we would use? All right, so now let's talk about algebraic expressions. Algebraic expressions. We looked at numeric expressions. And a numeric expression was simply 4 plus 3. It was simple. An algebraic expression is something like 5m plus 6. This is algebraic because it not only involves numbers and operations, but it also involves variables. And because it can change depending on what the variable is, that's what makes it an algebraic expression. The goal that we're going to look at, the first goal we're going to look at, is how do we translate something in English, something written, that we want to write into an algebraic expression. And one of the things we start with right away, the easiest thing to start with, is defining a variable. What is the unknown in the sentence or in the problem? And what is the situation? We want to look at the most important words. And what variable are we going to use and how are we going to use that in the algebraic expression? A lot of times we try to use variables that are close enough to what the actual word is to make sure it makes sense. So we remember it, because as you get farther on into math, maybe you have 2 or 3 variables and you want it to make sense, or so you remember how to do it. But for example, let's take a sentence that might be something like this. No, not T, not the. Let's do it right here. $3 more than the cost of a sandwich. $3 more than the cost of a sandwich. So that's the words. What is the unknown here? What don't I know in this statement? Well, what I don't know is what is the cost of a sandwich. So I'm going to let C equal the cost. And so if I want it to be $3 more than the cost, more than representing it's going to be an increase, maybe I'm going to add on to that cost. So that means that the algebraic expression would be the cost of the sandwich plus $3 more. And that would be 3 more than the cost of a sandwich. Let's have you try this one. Mari had $2 and made $6 an hour babysitting. Can you write an expression that indicates how much money Mary has? And can you think about that? Well, again, in words, what are we looking for? We're looking for the fact that Mari, well, you know what? Before I even say that, back up for a second. Why don't we pause here and let you try to figure out what this would be on your own. So pause the recording and write down what you think. Okay, so coming back to it, what does this mean? She had $2 and made $6 an hour babysitting. So whatever she made babysitting, she had $2 more than that $6 per hour. What's the unknown? Well, the unknown in this case is, how many hours did she babysit? We don't know that information. So we can't really figure out how much money she made babysitting right away. So the expression then, and what I'm going to do is I'm going to let H equal the number of hours that she babysat. So if she had $2 and made $6 an hour babysitting, she started with 2, and then we added to that 6H. because the number of hours times 6 would give us the amount of money she had total babysitting plus 2 more. Now we'll talk about some others tomorrow, but that's the basics for how do you turn words into an expression. The next part of this starts with a property, and it's one of our silly properties, but it's called the substitution property, and it's of equality. Now it's very important that you put that of equality on there, because we'll have properties that might be equality, they might be congruence, they might be similarity, they might be inequalities. We want to know which one we're actually using. So this is the property of equality. And what this property says, for all numbers A and B, if A equals B, then A may be replaced by B. All this is saying is this. If I had an expression, give you a sample expression, 2A plus 7, I could turn around and replace the A with B and make it 2B plus 7. It's a replacement. I'm substituting in, I'm going to substitute in for A, I'm going to substitute in the B and replace the A with the B. Now, let me give you a better example of that. And what we're going to do is we're going to do what's called evaluate. An evaluation is when we take an expression and we replace the variables with numbers. So for example, 3A plus 9 if A equals 5. So what I'm going to do is I'm going to replace the A with 5. 3 times 5, because 3A means 3 times A. It doesn't mean 35. You don't just put it in there. It is times, plus 9. Now using the order of operations, 3 times 5, that's 15, plus 9. 15 plus 9 is 24. So now I have evaluated the expression for a given number. Let me give you one to try. Evaluate 6 minus E plus F if E equals 3 and F equals 9. Pause the recording and give this one a try. All right, let's see how you did. If you did it right, you did 6 minus 3 plus 9. 6 minus 3 is 3 plus 9, and 3 plus 9 is 12. So you should have gotten 12 as your answer. Here, let's try another one. Let's do this one. C plus 5B minus 2A if A equals 4, B equals 8, and C equals 12. See if you could do this one. Pause the recording and try this one. All right, let's see if you got that one correct. You would have done 12 plus 5 times 8 minus 2 times 4. So of course we're going to do what's inside the parentheses first. 12 plus 40 minus 2 times 4. To the 2 times 4, and I get 12 plus 40 minus 8. And that would do 40 minus 8, and I get 12 plus 32. And 12 plus 32 is 44. So the answer I should have gotten is 44. Did you get that one correct? Are you talking to your computer again? That's okay. All right, besides coming in with your list of terms tomorrow, besides coming in with the question from before that I asked you to ask me about, which I'm not going to repeat, you can rewind if you don't remember it, I want you also to do the following two problems. I want you to evaluate if x equals 3, y equals 4, and z equals 7. And I want you to do z minus x over y, and I want you to do 5z plus x plus 4y minus 15. You do those two problems and you come in tomorrow and let me know what you got. All right, we'll see you tomorrow.